This is All Things ANSYS, the podcast from the technical support staff at PADT. Episode 109, we talk about industry best practices for vehicles and catch up on news and events from the world of ANSYS. Welcome from beautiful Flagstaff, Arizona. I am working from the Pines this week. It's a long story that involves a decision made 30 plus years ago that I ended up with a timeshare, and if you know the grift that is timeshares, they've shifted from fixed weeks to points, and the points are not really that good of a deal, so I kept my fixed week. So the reality is I get to spend a week in Flagstaff every year, which is not a bad thing. I think a good investment I made. My 25-year-old self made. So do enjoy it. This is the second time I recorded this because I guess there was a lawnmower in the background the first time and it didn't come out so good. So here we go again. Hopefully the sound is better. There's a lot going on in the ANSYS world, including an acquisition, which we will talk about. And I'm also happy to report that here at PADT, with our most recent hire last week, our ANSYS consulting team is now fully staffed. Although we do have openings in the ANSYS support team. So if you're still interested in working for PADT and would like to be one of those people that people count on for ANSYS support and training, do reach out and look at our website in the careers page and see where things are. And hopefully things have stabilized for all of you out there, and things are a little bit, it's a crazy world, and it's all sorts of not so nice things going on, but hopefully in your little part of it, things aren't too bad. So let's go ahead and get started. In our interview for this week, I talked with Jim Peters, our in-house expert on many things. And this week, we're going to be talking about using ANSYS products to simulate vehicles. As you probably know, this is one of the fastest growing areas for ANSYS, as the automotive industry itself is making the move to electric and autonomous vehicles. And simulation has become even more important with that move. And let's hear about all the different ways ANSYS products can help. Today we're joined by Jim Peters, and usually Jim would be talking to us about some new feature capability in a highly technical area of ANSYS, one of our core products usually. But today we're going to talk a little bit more generally about using simulation in the automotive space, the ANSYS tool set in the automotive space. So thank you for joining us, Jim.
Thank you for having me.
Yeah, this is kind of exciting. So you did a webinar that kind of went through a lot. So my first takeaway, or my biggest takeaway from watching that webinar was, yeah, we analyze a lot of stuff in cars.
Yeah.
Vehicles of all kinds. So it's a lot. And I don't think, if people want to know all those different things that ANSYS can simulate, ANSYS products can simulate, they can certainly go to Bright Talk and listen to the whole thing. But I wanted to hit the things that struck me as kind of cool, and that maybe engineers who are doing automotive systems or subsystems or in other industries might find kind of cool and interesting. So let's go ahead and get started with one of my favorite topics, even though we don't do enough of it, is acoustics. So there's a lot you can do. Of course, it's important with vehicles that they have a quiet ride. So what's going on in the ANSYS world when it comes to simulating that?
Well, certainly acoustics has become a much more important field of study for whether it's on the fluent side or whether it's being looking at subsystems using other tools. So I think probably the biggest takeaway is that acoustics capability is offered at several tiers of product. Certainly in the standalone legacy Fluent product, as well as ANSYS Mechanical, and there's acoustics in the Dyna world, and all of them are kind of geared for a specific, addressing a certain class of acoustics, whether it's noise and vibration or just cabin interior and so forth. So there's some of the newer products that have been brought to augment the legacy tools are really just being able to get a higher resolution decomposition of what the acoustic environment is, and VRX experience, coupled with Fluent to try to decompose sources of noise coming from external sources, tires, and airflow across mirrors, things like that, and then how much of that noise is propagated from the outside of the vehicle interior, and then obviously there's interior sources of noise as well, with heating and air conditioning, ventilation, and stuff like that. So, just trying to really get another finer resolution of not only just analytically extracting information regarding acoustics, but actually being able to study the components of it, and in VR experience, actually letting you listen to what the analytical noise would be produced is a really cool coupling of some tools.
Yeah. And for me, it was, in the past, it was how loud is it, right? This almost can tell you how annoying it is, right? Because you can actually hear, right? You can actually hear what it sounds like.
Yeah. And you can combine, audio sources in with results from an analysis if you want to combine known external sources that you don't necessarily want to model, but you want to combine that together. Okay. That's where that VR experience really does a kind of a cool job of kind of mixing those two things together, and it's really more of just an advanced post processor more than anything else. Fluent's still doing the heavy lifting of the calculations of pressures and so forth, but it's pressure is used in a lot of different ways, and acoustics is certainly one of those.
Yeah, it's really powerful, and so even if you're not in the automotive space, it's something to take a look at if you're not doing acoustic simulation, or if you're using somebody else's product. There's a lot in, like you said, in many different ANSYS products as well.
Yeah.
Cool.
Yeah, definitely.
Cool. Well, we could talk about acoustics all day, but let's move on. For some reason, I find it fascinating. So another area that's kind of that is out of my area of expertise, but seems to be really, really important, is this whole human interface design and heads-up display. So kind of designing what the driver sees in the car. So what can you share about those tools?
Yeah, those are some of the tools that have been recently acquired to be able to do lighting as well as driving simulation, and kind of combining all of those together. It's kind of in that Speos set of tools that is doing a type of analysis that without those kind of tools was never considered to be in the analysis space that ANSYS could provide. But now with those tools there, those have some incredible capabilities. With automotive vehicles, whether they're electric or not, turning into highly censored computers, basically, and then self-driving car capabilities, things like that. There's so many components that are a whole new level of complexity that needs to be addressed versus just the mechanical features of the vehicle itself. And those tools to be able to simulate these autonomous sensor features in good weather, bad weather. You've got the issue of you've got to make sure you're not producing false positive or false negatives in terms of sensor feedback. And that's, critical for autonomous vehicles and so forth. You've got to consider all of the conditions, environmental conditions that you may have to deal with in the implementation of something like that. It's not just something you can drive only when it's sunny out. You've got to be able to address how the vehicle controls itself in a variety of environments. And that's definitely something these tools are providing some really cool capability that way.
It was really impressive to look at all the different things you could do with it. And, And, again, yes, automotive is really driving it, but, aerospace, very similar needs, even sometimes medical devices and consumer products, you kind of have the same needs. It's just not a moving vehicle, right?
Yeah, yeah,
Yeah. It's cool. Cool.
yeah,
Well,
definitely.
speaking of moving vehicles, something that we do get to do every once in a while. That's one of our. I think your and my favorite types of simulation is crash simulation.
Right.
So that's certainly come a long way from modeling a wall in the car and running into the wall, right? I mean, there's so much in there now. So can you kind of give a high level overview of the different things like, the body model and the airbag models and seat belts and I was even really surprised that they have the standard models, I guess, for some of the test structures, the barrier structures that are used.
Yeah, well, and that's really where, vehicle crash analysis has really expanded, even before, the EV
Mm-hmm.
vehicle development kind of changed things even more. But there it used to be crash was just, the 35 mile an
Mm-hmm.
hour head-on
Right.
collisions, and yeah, that's good enough. Well, now, to get the full 5-star ratings on crash safety, which is huge for marketing and vehicles. Everybody wants to have the 5-star rating
The
in
standard.
every
Yeah.
category.
Yeah.
And every category requires these crash models not just to survive for a couple hundred milliseconds and then, let them go unstable. It's like, well, we need to be able to evaluate side impact. We need to be able to evaluate rollover. Potential of human being thrown out of a vehicle.
Mm.
Those kind of simulations are much longer, much more complex, and involve a lot of the safety systems built into the system. Airbags used to be a little easier in that they were only coming out of the steering
Right.
column, and it's just, you could approximate things a little bit easier. Now with curtain airbags and, airbags in every compartment of the vehicle, and they're designed to, come out in certain crash conditions. Now the secondary structure of the interior of the car is now becoming a critical feature to making sure that these curtain airbags deploy properly. And using uniform pressure inflation assumptions is no longer accurate enough for these kind of systems. They have very complex folding patterns, and they require a very detailed simulation of the expansion of the gas as it gets generated and as it fills up the airbag. So, crash analysis in general, there's a lot more conditions that need to be considered,
Mm-hmm.
as well as dealing with the kind of the whole change of a traditional combustion vehicle arrangement to electric vehicles, where now the critical component is the battery.
Right.
Batteries haven't been modeled in much detail in combustion engines because they're not a very critical subsystem. Now they're extremely important, and that's the new area of development on the Dyna side is how are we going to address damage to the battery? How are we going to simulate thermal runaway if cells start damage from a vehicle accident has caused the battery to start going shorting out and going unstable? How can we predict and how can we alleviate some of those problems? So there's a lot of new areas that have never really been dealt with before that the tools need to evolve to be able to handle answering some of these questions.
Yeah, and it seems like a lot of progress made there. Yeah, just amazing, all the different standards and capabilities and modeling these things. It was simpler.
Yeah, I mean,
No, but it's capable.
yeah, in general, a lot more to deal with, and then the resolution of everything you used to do, it needs to be even higher fidelity than it was in the past. So, with manufacturing construction techniques, changing with electric vehicles, that, there needs to be new best practices for modeling that, structure, and those attachments need to be done in a little bit more resolute way with electric vehicles as opposed to traditional vehicle construction. So
Yeah, yeah. That's so true. It's really, really, really pushing it. And the expectation of the driving public, the buying public, is that these cars are going to be 5-star safe. So you got to do all this work.
yeah, definitely.
Yeah, it's true, true. So the next area I want to talk about was new to me, and the title given was water management and soiling. But it was very cool. It's how when you drive through a puddle, what does that do? Can you talk a little bit more about that type of analysis and how it's actually done?
Yeah, the water egress, that was something that could be, quote, simulated in the CFD world with kind of a Euler domain and so forth. But it is very computationally expensive to try to do it there, and it never was really practical to do at a scale of a moving vehicle, over a 2 or 3 minute time period it takes to go through the bath. So one of the things that has been happening on the Dyna side is, there's a variety of different particle methods available that are used in airbags and a lot of different applications, but they've developed a more simplified implicit based SPH formulation to replicate the water. So, the level of detail that may be needed for compressibility effects and all that kind of stuff for more complicated analysis have a more complicated formulation that it's more expensive. But this implicit method allows, a good bulk representation of the water, and with it being a particle method allows you to be able to track splash patterns and everything, egress of hey, do we have any areas that there's the potential for leakage coming in? And a particle method is a whole different level of resolution that can be captured versus a traditional Euler domain or Lagrangian domain representation that would be very difficult to kind of handle these seams and egress areas where it would be difficult to have the physics be captured in that style of physics. But the particle methods provide a tremendous capability of not only high resolution result, but also the ability that these particles just act on top of whatever structure you have. So it makes the simulation of those so much easier. And this particular implicit formulation is significantly faster in the solve time, can still, like I say, capture the behavior of water and how it reacts to the vehicle being driven through it. But that's one area where the basic capability has always been there, but now we need to find more practical ways and faster ways of being able to do it with the level of accuracy for that particular application. So
yeah, it's pretty cool. And again, yeah, that's very useful for cars, but there's probably a lot of other industries that have water or liquid splashing around. They want to be able to model it. And so, yeah, that's a capability that we have now to be able to do fairly easily. So pretty cool. Pretty cool. So we haven't talked about external flow. We haven't talked about structural simulation, brakes, exhaust, modeling the engine. These are all things that I think people are aware that ANSYS has done for some time.
Yeah.
Was there something we didn't talk about that maybe impacts the overall simulation of vehicles that you think is people need to know about because it really makes a big difference?
Yeah, I think if you look at in the way this presentation was kind of formatted, it is, bottom line, modern vehicles are much more complicated, have so many more things to consider in their development. And
Mhm.
just as they've always had, you need to do them faster. You've got to get the design cycles down to fractions of what they would normally take in traditional methods. And probably one of the biggest, this presentation was really a highlight of the ANSYS portfolio of tools to address all these different areas. But probably the one tool that is, the most overreaching that would cover so many of these areas is related to materials, the
Ah,
Granta materials
ah,
system.
okay.
So, that's a traditional problem in any industry is consistent, use of the same materials for all applications. And and there's certainly material data that's specific to different types of physics, but overall, you would like to have a central source that everybody's using the same material definition. And that's traditionally just been a very problematic, and it's probably very difficult to assess the impact of how much extra effort gets involved when you don't have tight control over your materials. People using different material sets and making decisions based on those values that other material representations might be different and lead you to a different conclusion. And so there's a lot of issue that way. And, the presentation of the Granta, MI system to be able to capture all of the, you know, customer proprietary materials
Right.
coupled with external sources of databases that are available for plastics and rubbers and composites, having one central source that would be the storage of all that material, and then it has interfaces that are formatted for the specific use case. So the CFD people need a certain subset of material information, and that could be, directly put into Fluent right from that interface. And then the structural guys have theirs. On the Dyna side, they have theirs. They need,
Mhm.
much more complicated material definition. So having that central source of materials that can be used across all, avenues, and understanding not everybody needs the same material data, but a central source where all of that is captured and stored, I think is probably the biggest thing that would lead to these design cycle gains, is because the materials and getting all the materials set up for each of these individual simulations is not a trivial task.
No.
And control of that material is not a trivial task. So having a system that you do have control and traceability back to the source,
Mhm.
I think that's probably the biggest, product piece that ties all those other individual products together,
Mhm.
that would really make, a system level analysis
Mhm.
so much more efficient.
Yeah. Yeah. And what a change, right?
Yeah.
I think some larger companies tried to build their own databases. I think we all use Excel far too often to this problem.
Yeah.
And they're certainly not traceable or repeatable or shareable to the extent that this is. So, yeah, Granta, it doesn't get as much credit as it deserves, especially when you're working on large system machine. I mean, it's all machines, right? We're modeling machines, right?
Yeah.
So
Yeah.
vehicles, aircraft, medical devices, right? They're these complex ones that
Yeah.
use these different physics and these different simulation tools. Having one tool to manage the materials is huge. So,
Yeah.
yeah,
Well, I
very
know
good thing.
just in my simulation work,
Mhm.
I use the grant to, commercial database of materials, and I've saved a tremendous amount of time in my workflow
Yeah,
process of not having to Google materials, and it's like, oh, let's go look for tungsten, and it's, oh, well, which version?
yeah,
And
exactly.
all of that in one central source that you can just grab it. It's populated with the data you need, and that's
Yeah.
an aspect that, like you say, isn't well communicated sometimes, but that's a huge part of the
Yeah.
workflow process.
Yeah. Improving efficiency as well as accuracy. Yeah. Yeah. So true.
Yeah,
Well, oh,
absolutely.
cool. It's very hard not to talk about all the more mundane things that are in there, but we won't. And maybe we'll cover some of those at some other point. Um, a little shout out to the series that we're doing of webinars where we're looking at industry best practices. This was automotive, so they're really overviews of how you can use ANSYS tools in a given industry. And strong encouragement, even if you're not in that industry, as we've talked about here with some of the stuff that's we're talking about in terms of automotive. It's applicable, of course, to other industries as well, and pretty informative stuff, and maybe simulations you didn't know you could do or don't do enough of. So it's great series.
Yeah.
Anything else you want to add? I think that's all we have time for. But anything else?
Yeah, no, I think just, the general message is, the legacy products continue to be enhanced to be able to handle the challenges and the resolution of information that's required. And then, the integration of new tools that address specific things are constantly going there. And like I say, I think the series is a really good exposure to, oh wow, I didn't know they could do that. And yeah, the ANSYS portfolio of products is ever expanding and has tremendous coverage.
Yeah.
And just being able to see that at a high level of, oh wow, okay, I didn't know that could be done. That's why I think the value of this series is just introducing people to products that they may not be aware that existed.
Yeah, agreed, 100%. Well, we'll have you back on in the future, hopefully with some more. And
Sure.
otherwise, you have a great weekend, and we'll talk to you soon.
All right. Thank you very much.
Thanks, Jim.
All right.
Welcome back. If you have any questions or want to know more about any of the topics we covered, please reach out to info@padtinc.com or podcast@padtinc.com. And we covered a lot, and we only scratched the surface. So please do reach out if you have any questions or want to know more. Like maybe there's a capability that you think we might have that you didn't hear about. Let us know. So for our commercial this week, want to talk about how last week I was at IME West, and that's the big design and manufacturing show in Anaheim. MD&N, D&M, used to be called the Pacific Design Show. Anyway, it's a big show. And the week before that, I was at the Space Symposium. And people stopped by our booth to chat. I found myself talking about PADT as a whole, and then the various particular services that we offered. And I thought, hey, I haven't done that in a while on the podcast, so let's make our commercial a little bit of the background on PADT and why we do so many different things. So the four of us started PADT when we were engineers at what is now Honeywell Engines. We were turbo machinery engineers, and we did three things that were new at the time. We did 3D printing, which was called rapid prototyping. We did advanced design. 3D solid modeling was really new at the time. And we were doing 3D simulation using ANSYS, a commercial code, rather than in-house codes or government codes. And we thought, hey, these technologies are going to be applicable to other places out there. So let's go ahead and work it that way. Let's go ahead and build a company around this idea of these three different technologies, these CAE technologies. And PADT was born. And here we are, 28 years later, and we're still basically those three verticals, right? So the simulation team, the design team, and the 3D printing team. And we also, one thing that changed from that original consulting goal is we sell products. So you all know we sell ANSYS. You should probably also know we sell FlowNext if you listen to this podcast. But we're also a Stratasys distributor for 3D printing, as well as EOS for metal 3D printing. And we also sell Zeiss scanners, Zeiss and GOM scanners, actually. So we've got a whole group of salespeople and support engineers and field service engineers for that sort of stuff. You also know that our ANSYS sales and support provides training to folks, But what you may not know is we offer the same sort of thing on the 3D printing side. We have classes on how to do 3D printing, how to design for 3D printing, and of course we support the 3D printers that we sell. And the reputation we have in the ANSYS world is replicated over on the additive manufacturing world. And our consulting team, which we often talk about here, that does simulation, we also have another group of people in the same department that do product development. And they do project management, electrical engineering, mechanical engineering, and they can pretty much design, build, and test anything. And we do that across industries, including a group that does just medical devices. Then over on the manufacturing side, we have one of the most well-respected 3D printing service providers in the country. If you want to just throw your parts over the wall, get a quote, get a part, that's not us. If you want help, if you want engineering, if you want the right process, the right post-processing, definitely reach out to us. And we offer a variety of consulting services around manufacturing as well. So that's a very high-level overview. Here after 28 years, we're kind of still doing the same thing. And hopefully we can help you do those things better. So please think of PADT beyond what you know us for. We're 90 people dedicated to making your innovation work. All right, so let's take a look at the ANSYS stock. And well, I guess I could have skipped this. It's actually down 29% for year to date. So here we are. I'm recording this on April 17th. So around 11 o'clock Phoenix time, it was sitting at around 29% drop, which was, let me see here, $281.66. Now the S&P 500 is down only 8%, so it's definitely the ANSYS stock is underperforming, but so Altair and Autodesk, they're at minus 26% and minus 30% respectively. PTC is the only stock that we really look at in this area that's not performing as bad as the other three. They're only down 18%, so they don't suck as bad. This is even after the acquisition that we're going to talk about in a second. And the other bit of news on the ANSYS stock standpoint is they will be releasing their Q1 numbers on May 4th. So I always recommend people listen to that. Of course, we'll talk about it on the podcast after that. In ANSYS news, there's really only one story, which is that ANSYS acquired a company called OnScale. Now, I confuse OnScale and OnShape. OnShape is a cloud CAD platform. OnScale is a cloud-based simulation platform. And it's a native 100% web-based user interface and built to run and solve in the cloud. There's no emulating or anything like that. It's native built in the cloud. And so ANSYS acquired them, and they're basically going to they're going to take the solvers that came with the OnScale product and replace them with the ANSYS core product solvers. And you're going to be able to do true cloud computing, high performance simulation computing, rather than really running a virtual terminal in the cloud, which is what we do now, which fits a lot of situations. Sometimes you want to do true cloud computing. This is going to be the way to do that. It's a full multiphysics user interface. And I'll read you, I'll kind of paraphrase because they're kind of long and markety, the bullet points that ANSYS put on the press release. So they basically point out in the first bullet point that the current marketplace and cloud portfolios that ANSYS offers they provide the scalable, location-independent access to the industry-leading applications that ANSYS has. So the full-featured user interfaces that we have on those tools, you can access on the cloud. Again, that's kind of like running a virtual machine in the cloud rather than on your desktop or in a server near your office. So that's what we have right now. And this portfolio will extend that with the addition of this cloud-native web-based user interface from OnScale. So when you want to do that, that's the right tool to have. So once OnScale's technology is integrated with ANSYS portfolios, customers will enjoy device-independent access to ANSYS simulation via both full-featured UIs, which is what we have right now, and this new fully web-based UI, which was just acquired. The OnScale technology will also support ANSYS's ongoing extensible platform-centric approach to enable a new class of simulation-based vertical applications. What does that mean? It took me a while to figure that out. What it means is that it's going to support the Python that we're writing APIs in across, most of the major products are already there. Other products are getting more robust in this area. So you'll be able to actually write, and this is really important, vertical applications using the OnScale product that write in the cloud. So if you want to write a vertical application that does simulation for your customers, this is the secret. This is where I think it's going. You can do that with this product. So you can create a vertical app to say, let's say you do electronics and you want your customers to be able to do thermal models of your geometry. You can write a vertical app for them to do that using this on-scale technology rather than the native GUI that is emulated on the cloud. So pretty cool. I have not used on-scale, I'll be honest. I remember when it came out, I looked at it. It looked pretty slick as far as a user interface standpoint. But we'll see what it is and what it looks like as we get used to it. We'll talk more about once the deal gets done, right? They announced the acquisition. It's still not completed. Once that's done, we'll try and get somebody from the team, from both, like we usually do, somebody from Ansys and from the OnScale team to come on and talk about what they plan to do and what the applications are going to be. So I'm pretty excited for a lot of different reasons, new users, but I think the big killer app of this acquisition is going to be our ability to create cloud native vertical applications using the OnScale user interface. Pretty cool stuff. That's pretty much it for Ansys news. PADT, we did have a press release go out that we announced that we're now selling 8 new 3D printers from Stratasys over the last little bit over a year, maybe. It's been about a year. They've announced a lot of new platforms, not just new FDM and PolyJet printers, but also a new powder bed system, as well as stereolithography and projection-based through acquisition and development. So really cool there. If you're interested in 3D printing, do check out that press release. Let's go ahead and hop over to the Ansys blog. Pick 3 stories. Again, these always, you don't have to go by me. You can check out the blog yourself and see what interests you. These are the 3 stories that interested me the most, and you can tell what I like, which is alternative energy and medicine and anything in space. So the first one, speaking of medicine, is simulation helps bring new drugs to patients faster. It's how you can use Ansys tools in the pharmaceutical industry and drug delivery industry. 3D printing innovate. The next story is 3D printing innovation takes off at NASA. So I like this one, of course, because it combines space and 3D printing and simulation. And one thing that a lot of people don't realize is a lot of the 3D printing going on in space is, of course, powder bed fusion, where they take the laser and melt the powder. But there's also this direct energy, which isn't used in a lot of other industries, which is basically spray metal. And that's how they're creating these big pressure vessels. So there's an article on using simulation to help drive both of those. And last but not least is called X1 Wind Floats Unique Energy Harvesting Technology thanks to the Ansys Startup Program. So I always like to point out how the Ansys Startup Program is a great way for startups to get into the world of simulation early on at an affordable price and drive your design and cut your costs, your development costs, by using virtual prototyping. And this is such a great example of it. And it's a pretty cool tripod-based floating wind turbine application. So check that out for a lot of different reasons. On the PADT blog, our new website is almost 100% done. We've still got a few pages that are getting fleshed out. It's up and running. There's just a few things that probably don't make sense if you dig deep enough. Those are getting fixed. But everything else, especially on the Ansys side, is completely done. It's up and running. So let us know if you find any broken links or format issues in those old blog articles. I mean, some of those blog articles are 15 years old, and they've been moved like 4 or 5 times. So if anything's not working, please do let us know at info@padtinc.com. We have published 3 blog posts since the last time we talked. The first one is from Alex Grishin. It's called How to Perform Equilibrium Checks on Transient Heat Transfer Numerical Models. And this is a question we get a lot in tech support. So Alex did a PowerPoint. You can take a look at that and learn from him. Very useful if you're doing any kind of transient thermal simulation. Definitely check that out. Then the second one is a Flownex article from Miles called Using Property Monitor to Pause a Simulation in Flownex. Very important tool. And the last is actually on the 3D printing side, and our very own Pam Waterman, who is an expert in 3D printing and an author on the topic, went with Women in 3D Printing Arizona down to a subdivision that's being built for Habitat for Humanity using 3D printing. So one of these concrete 3D printers. Very cool application. And she kind of explains the whole thing. So if you're interested in building with 3D printers or buildings made with 3D printers, check out that article that Pam wrote. It's in our blog as well. Upcoming events-wise, we have our next webinar is going to be on the 20th, which is, I got to check what day of the week that is. That would be Wednesday, as usual. It's called Additional Fluids Updates in ANSYS 2022 R1, Ensight, Chemkin, CFX, and Forte. So we're going to talk about these other fluids products instead of just Fluent. Definitely check out the Ensight one and CFX if you use those tools especially. And then the following seminar is going to be on the 27th of April called Simulation Best Practices, and that's a Wednesday as well, for environmental pollution control. So just like the vehicle best practices one that we talked about with Jim's interview, this one's going to be on environmental pollution control. So if you're doing any kind of combustion where bad stuff comes from the mixing of various things, this is a good one for you to check out. So those are the two webinars that we have coming up. Other things going on in our world are on Wednesday as well. The final stop of the Experience Stratasys Tour will be stopping in Tempe, Arizona. And that's going to be, again, on Wednesday. And it's down at ASU. It's just off Mill Avenue on Lot 20, if you know where that is. So we'll be showing off Stratasys 3D printers there. Good opportunity for you to check those out if you live in the Phoenix area. And then on, I guess the only other thing really worth pointing out coming up is on April 22nd, we will be at the 12th Annual Tucson Arizona Technology Council Golf Tournament. So if you're golfing at that tournament, do let us know. I think we've got one more slot left as well on the golf tournament. So if you want to golf, reach out and let us know if you're listening to this podcast before then. That's the 22nd. Again, that's a Friday. And then we will be at Rapid. A couple folks from, including my partner, Ray Chu, who's the true expert in 3D printing, will be at Rapid from the 17th to the 20th. And don't forget, Simulation World 2022 is May 8th. This is an ANSYS event. It's a conference, and it's a virtual conference only. And it covers all things about how to, not necessarily into the technical side of simulation, but more the business side of simulation and the application side, the project management side. And lots of good case studies of how people have used ANSYS tools to change the way they do product development. So that is it for events, and that is it for our podcast on this second take. Hopefully much clearer without the lawn noise in the background getting modulated by the sound software. Kind of makes it go, whoa, it's really annoying. So I redid it. I want to thank you all, as always, for listening. Don't forget to subscribe at www.padtinc.com/opt-in. Again, that's for our newsletter, so you can get news about what's going on in the world of PADT. And subscribe to the podcast wherever you get your podcast. Do spread the word, let other folks know about it, and do not hesitate to reach out. Thank you for joining us for the All Things ANSYS podcast, episode 109. As a reminder, this podcast is not affiliated in any way with ANSYS Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.